is the button. And then we'll share the screen. There we go. Okay, morning everybody. Welcome to our big data class for today. Last week, all of last week, we covered that Pagilla Homework 3. Again, Pagilla Homework 3 was not due this past weekend, but the Pagilla Homework 2 was due yesterday. If you haven't turned it in, which is okay, about half the class hasn't, you still have until Tuesday this week with the collaboration extension. And then the Pagilla Homework 3 is going to be due this coming Sunday. Today, we're going to be talking about a new homework assignment that combines all of the stuff that we've been talking about with Postgres and building off the knowledge we learned from the Pagilla database, but also combining it with the Twitter assignments. I'm going to switch over to this Sakai. Oh man, it locked me out, the Sakai. Let's see, I'm going to log back in here real quick. Take a look at this. And I'm bringing this up just to show the due dates for the upcoming homeworks, all listed in one place. So again, the Pagilla Homework 3 due this coming Sunday. And then the following Sunday, 2 weeks from now, we'll have 2 homeworks due. The Twitter map reduce homework is, we've had that sort of outstanding for a long time now. That's using Bash and Python just by themselves to analyze this big Twitter data set. And then starting this week, we'll be talking about how we can do that in Postgres and make things maybe more efficient in certain ways. This is going to take us a while to get through talking about integrating Postgres and Twitter. So this is not the only assignment that we'll have related to this, but this will be the first assignment that we have related to this. And so I'm spending a little bit of time just talking about this, just to highlight that both of these 2 assignments will have the same due date here. And this Twitter map reduce assignment, again, not something that everybody has to do, but there's still about 15 or so students in the class who have to complete it. And I recommend, again, 2 reasons for getting this one done early. One is because it can potentially take a long time computationally. The second one is that this second Twitter Postgres assignment will make more sense after you've done this one here. It'll be easier to do combine Twitter with Postgres if you've already done stuff with Twitter. The other thing, sort of timeline-wise, to keep in mind is that, again, my wife is pregnant. We have our baby due. The due date is actually this Wednesday of this week. I've been expecting, I was expecting all of last week that the baby would be coming because our other babies have all been coming super early. But probably the baby will come this week at some point, and we'll be taking some time off of class when that happens. I'm open to the idea, possibly, of extending these deadlines when due to the baby coming, if the baby comes, which certainly will before March. But you shouldn't count on that. You should be anticipating that this is the sort of deadlines a week from this Sunday. Any questions on anything administrative? Doesn't. Correct. Anybody who has completed this assignment in any way for me in the past, and so in particular, if you've taken CS46, then there's no need for you to do that for this class. This assignment is only for the people who have not already completed it in some form. Good question. Any other questions about anything administrative? Good question. The question is, do we have a date for the midterm? And the answer is, we don't have a particular finalized date. again, because of the ambiguity about the baby coming. And I want to make sure that we'll have sufficient time to have some review sessions before the midterm. And so I don't have a concrete date for the midterm yet. All of the material, let's see, today is sort of the I guess dividing line on midterm material. Anything before today is fair game for the midterm. So anything on the Pagilla homeworks and back, fair game for the midterm. Anything that we cover after today will be for the final exam and the upcoming homework assignments, but won't be on the midterm. Another way of saying that is the midterm will be on SQL questions about the correctness of SQL, and today and on, we're talking more about the efficiency sort of things rather than correctness. So the approximate date for the midterm would be the sometime in the week before spring break. But we'll finalize that once I know when the baby is arriving and we know exactly what the schedule is going to be like. So I apologize for the lack of certainty on that, but that's how things are at this point. Great question. Any other questions about anything administrative in the class? How is the Pagilla homework 2 going? Okay, a lot of thumbs up. Okay. Okay. So we have a week 6 folder posted. That's what we're going to be going over today. And inside of this folder, there's a link to this Twitter Postgres submodule. Again, we know this is a submodule and not just a folder because it has this @ sign with the commit hash to the right of the @ sign. And if we click on that, it would take us over to this Twitter Postgres repo over here. And pretty much going to spend the whole day today going over the just like the formatting of this homework assignment and repository and exactly what to expect from the homework. There's the first thing that you'll notice that's maybe different about this assignment compared to the previous is now there are 2 of these sort of test case badges here instead of just 1. And if you look at these, this says tests denormalized and tests normalized. Let's maybe make this a little bit bigger. There we go. And so last time we were talking, or last week, we talked a little bit about the difference between denormalized versus normalized representations in databases. It's a little bit maybe at a high level, theoretical. This week, things will get more concrete and actually doing it, implementing things and working with the different representations, seeing their advantages and disadvantages. In this assignment, in this assignment, I'm going to switch over to the terminal here so we can take a look at some of the files. And so I'm currently in our week 6 folder, and then inside of the Twitter Postgres folder inside of that, type ls. There's a bunch of folders and files in here, more than we've seen before. And one of the things that's different about this folder or this assignment than the previous ones is that the data is coming in the form of this zip file right here, and it's not a link to another repository. We'll open up this zip file here in Vim for a second. So testdata.zip. We see that there's one JSON file inside of here just called example.json. And if we look at this, this has the same format as the data in that Twitter dataset folder. It's just sort of a smaller version of that. I'm going to press Shift-G to go to the end of the file here. There's about 10,000 lines here. So it's just a much smaller version of the data, but it's still formatted the same way, has some particular important edge cases in it that will test your code. But in order to make our project work with GitHub Actions and run reasonably quickly, we're going to have to use the smaller data set at this point. And then once we get it working with this smaller data set in this assignment, in the subsequent assignments, we'll be extending it to the bigger data set with more data. So at this point, smaller data set just to get things working, get our sort of feet wet integrating this data in Postgres, and then later on we'll be working with the larger data sets. :Q, exit out of this. Another thing that you'll notice inside of this services folder, so ls services, there are now 2 services instead of 1, and there are 2 different versions of the Postgres database, the denormalized and the normalized. If so I'm going to do vim here, and we'll do pg denormalize, control C, vim services tab / pg underscore denormalized, and then, well, let's see, let's just go ahead and ls the files in here. 2 files, a Docker file and the schema.sql. The Docker file is basically the same between these 2 services, and basically the same as the Docker file that we had before, just loading up Postgres and loading the data. The thing that's different between these 2 services is the schema.sql file, schema.sql. And let's see, I'll do a little magic on the command line here for a second. So I'm going to open up, and just to see that the contents of these 2 folders is basically the same. It is with denormalized, there it is with normalized. And what I want to do is I'm going to do, in one command, open up these 2 SQL files at the same time so that we can compare them against each other. And so vim services, do tab, and then / schema.sql. Again, this star right here is going to expand to match sort of anything that is in the services folder. There's only 2 things in the services folder, pg denormalized and pg normalized, and they both have a schema.sql inside of it. So this right here, let's go ahead and replace it with echo just to see what it expands to. It expands to these 2 files right here. In order to open up multiple files at once in vim, you can do vim and then -p, the -p flag. I don't know why it's -p, but what it does is it allows you to open multiple files at once. And now you can see I have 2 of these files opened up here at once. This left one right here, do :E, it'll tell me the exact name of the file down here. Services /pg denormalized /schema.sql. And then on the right over here, :E, this is the normalized one on the right. The difference between the normalized one and the denormalized one is that the denormalized one has only a single table inside of it. This tweets_JSONB, only a single table. And we'll talk about this JSONB type here in detail today. But the idea is that it just stores like the JSON information in raw form.
How did you open the 2 tabs again?
Yeah, question is, how did I open the 2 tabs at once? I did vim, then -p, then the name of all the files that I wanted to open. And that let me open up all these files at once on the command line. Actually, while we're talking about being on the command line right here, I don't want to say this is a mistake, but one of the things that sort of maybe more novice command line people do is that if there is a particular file that you want to open in vim, you will cd into that folder. So if I wanted to open up this schema.sql right here, then I might cd into services and then into pg denormalized, and then do vim schema.sql. There's nothing necessarily wrong with that, but it ends up being a lot more inefficient because then when you want to look at another file, you have to cd again, and you can't easily open up multiple files at once in vim that are in multiple folders. So in general, whenever I'm working on a project, I always keep my working directory, my PWD, keep it to be the root folder for the project. So in this case, Twitter Postgres, that's the root folder for my project. And then I never cd again, never change my directory. And if I want to open up a file, I'll just type out the full relative path to that location. So something like cd services /pg denormalized schema.sql to open it. And yeah, it may seem, for for whatever reason, actually typing out relative paths, a full relative path that includes subdirectories, is a little bit unnatural to people first using the command line, but it'll make you makes you more efficient, and it makes you able to avoid bugs with running things in different working directories. So I always keep my working directory to be the root of the project. But the actual question again was, if I wanted to open up multiple files at once in Vim, how do you do that? Vim-p flag required for opening up multiple files at once. Without the -p flag, it opens them up sequentially. It'll open up the first file, then when you quit that, it'll open up the second file. So -p, and then this command right here, the star, the glob, expands to get all the schema files. So the left-hand tab, again, :E. Oops, I did not press :E. What did I press? :E like this. :E, E stands for edit. It'll tell you the full name, the full path of the file that you have open. So it's the denormalized one on the left. And GT, switch tabs, :E tells me it's the normalized one on the right. And again, the difference between the normalized and the denormalized files is how the data is represented. On the left, in the normalized, we have just a single table, this tweets_JSONB, and the data is just going to be loaded using this JSONB type, basically just copying and pasting the information we have in the zip files directly into the table here. And then on the right-hand side, the normalized version. Again, normalization is the process of sort of chopping up a table into multiple parts. Here, we're going to be split up into many, many different tables. We have a URLs table, a users table, a tweets table, and so on. And each one of these tables has a very big schema with a lot of different columns associated with it. Over back in the README file in the Twitter Postgres assignment, if we scroll down a little bit, there's this diagram right here. And there we go, this diagram right here, which summarizes the whole schema of the normalized version of the table. All of the information that's stored in both of these two databases is the same. It's just represented in different ways. Last time we were talking about some of the different types of relationships that data in a database can have with each other. In this case, there's really like two fundamental important tables in this database, the tweets table and the users table. Every user can have multiple tweets. Every tweet corresponds to only a single user, so there's a one-to-many relationship between the tweets to users along this id users path right here. Each one of these arrows represents a foreign key from the table on the left to the table on the right. So inside of tweets, we have an id users column, and it must contain something in the users table over here. This again is the one-to-many relationship between tweets and users. We also have this tweet_tags table. I'm gonna switch back over here, do / to search tweet_tags. This sends me to the tweet tags table. And down here in this table, there's not a whole lot of things. So we have an ID tweets and a tag text. And this is just representing all of the tags that are in this particular tweet right here. There can be many tags in a particular tweet, so this has that many-to-one relationship, many tags inside of one tweet. We could have represented the tweet, this sort of many-to-one relationship, in an array inside of the tweets table, and that would be some sort of, that would be a less normalized version of this database. But in this case, we have done a lot of normalization and separated out into as many tables as possible. There's no arrays anywhere in this database. Any questions so far about these two databases? What's different or the same about them? Okay. What we're going to do next then is we're going to take a detailed look at this JSONB type inside of the tweets JSON right here. We'll take a detailed look at this JSONB type and how to use it and how to access the information from the database using this type. If we come back over to the lecture notes over here and scroll down, this first section in the lecture notes has like a summary of what's going on with the JSON-B type. So again, we're in our denormalized representation, we're storing everything in JSON-B. This JSON-B, the JSON stands for JSON, the standard format, and then B stands for binary. Inside of Postgres, there happens to be another column type called JSON, which you should never use. This exists only for sort of historical and backwards compatibility reasons, so don't use it. If you're interested in the full history of JSON support in Postgres, this video right here is the thing to look at. If you would like, you can watch this video for one of your caveat tasks. And I have the video pulled up right here, just this one screen. So you can see there's sort of like a timeline going on of different developments. Sort of people started this process in 2003. This guy up here on the right, his name's Oleg. He's sort of the main contributor to, or the sort of like the driving force behind JSON support in Postgres. And one of the things that I like about this, besides like the technical details, but on the social aspect, one of the things that I like about this is that this guy is a Russian, and this whole process has involved a lot of international collaboration between people in Russia and the US. Postgres is a truly international project. There are a lot of open source projects that are not international. So if you think of things that are coming out of like Facebook and Google, like React or Hadoop even, and yeah, most of the famous open source libraries, they sort of have maybe one company driving force behind them, or like one country that has a lot of developers. Postgres, not the case. And so Russia and American developers actively collaborating with each other as our politicians are trying to get both of our countries involved in a war with each other. But so summary of this history of JSON support. So back in the day, MongoDB was released in 2007. Its sort of killer feature was that it was based around JSON. And in general, most NoSQL systems are based around JSON. And because people really like JSON, NoSQL became really popular in like the 2010 to 2014 timeframe. But looking at this roadmap, you can see here at 2014 is when JSON-B, this type, was introduced. And at that point, Postgres had strictly better support than MongoDB for JSON. So anything that you could do in Mongo or any of these NoSQL systems, you can do better in Postgres. And there's only been more improvements since then. Another cool thing about Postgres, they've sort of led the standardization effort of getting JSON into the Ansi SQL standard. And currently Postgres is really the only database, RDBMS, the relational database system. So excluding NoSQL, but actual proper databases, RDBMS is. It's the only RDBMS that has proper JSON support. So things like MS SQL, MySQL, SQLite don't have the support. Oracle has extremely limited version of this support. Any questions about any of the history, social things about JSON support before we get into the technical details?
What are the Ansi standards you talked about again?
Question is, what are the Ansi standards?
Yeah.
Yeah, so I mentioned that there's this Ansi standard right here. And so this SQL language, the S in SQL stands for standard. So it's the standard query language. And the idea of SQL is that you can use this one standard language for accessing any database. All of the SQL features that we've seen in Pagilla, with the exception of arrays, is a standard feature of every RDBMS system. And so whether you're using MS SQL, MySQL, SQLite, you can use all those features just fine. JSON, so Postgres has gotten it into the standard. but these other systems are sort of lagging behind Postgres and don't have support for it. Arrays have a similar story that it's part of the standard, but these systems just don't have support for it. So that's, if you really need like compatibility with multiple different database systems for some reason, JSON support is not something that you'd want to use, but that's rarely the case. Usually you're just like sticking with one database. And so one of the reasons why you might want to choose Postgres over these other ones is it has good support for these things like JSON. Did that answer your question, Drew? Maybe. Last thing before getting into the technical details is that if you pay close attention to these notes up here, you'll see that sometimes like JSON is in the backticks in this like code formatting, and sometimes it is not. And there are no typos in here. Pretty confident there's no typos in here, and that this is sort of the correct, all of these choices are correct. And the reason that this is at like a code formatting is because this is referring to a particular concrete implementation of JSON, a particular type inside of Postgres. This JSON right here is not referring to a particular type or a particular implementation, but sort of more the platonic abstract ideal of JSON in general. And one of those sort of shibboleths about how you can identify a more experienced programmer from a more junior programmer is their ability to use these sort of grammatical cues correctly to indicate whether something is like a concrete implementation. It's like you're quoting from the source code of the Postgres implementation right now when I do this. Here I'm not quoting a computer, I'm referring to something like human concepts, so it's not in backticks. So separating out the human from the machine concepts, important skill for communicating your competence as a programmer. Okay, so now like concrete technical details. These 6 bullet points right here are the things that you'll need to know to understand about JSON. And I'm going to switch over to our terminal here just to illustrate how all of these things work. But this is sort of the list, the canonical list of things that you should know. Coming back over here, up here, let's, I believe I already have my system up. Yep, it's up. See, there's 2 databases right here that are running. And let's, actually, what I want to do, first of all, I'm going to type out the command in full docker compose, and then I want to do exec. And we've seen before, I've used tab completion to complete like file names. Tab completion can be used on things other than file names as well. So here I have two services. Maybe let's down here, I'll do :0 tab E. The 0 out in front means that I'm going to open up my tab in position 0 in this list, so it'll appear on the leftmost position. And then I want to open up the docker compose.yaml file. Just type do and then hit tab is why I completed so quickly, hit enter. And here we can see there's these 2 services, PG denormalized and PG normalized. Again, corresponding to those 2 folders in the docker compose, or these 2, control up here, the 2 services in the services folder. That's what these 2 services correspond to. But we're talking about this right now because I do not want to type out PG denormalized. That is a big word with a lot of letters in it. I'm likely to make a typo, make a mistake somehow. So let's do docker compose like this, exec. And then if I press tab right here, it will start tab completing these services for me. So normally, again, tab completion works with file names, but for particular commands that don't take file names but take something else, tab completion will work with that something else. In this case, it'll work with the services down here. And so I just pressed tab and it put in that PG underscore for me, stopping before it got to the different part. I want to open up the denormalized database. So I'm just going to type D, and I don't have to worry about typos. I'll just hit tab and it'll complete out denormalized for me like that. And then I want to do pSQL like that, and there we go. We can do, so we said there is this tweets underscore JSON B table. that we saw in the schema over here, there's this tweets underscore JSONB table, has one column inside of it called data, its type is JSONB. One column data, its type is JSONB. If I do select star from that, select star from tweets underscore JSONB semicolon, and it'll take a second to load that up. There's a lot of, where's the information? I'm going to zoom out just for a second so that it'll appear on the screen. It's not going to be important to be able to read it super closely, but if you look, maybe now I can zoom back in now that we're down to the right spots. You look, it'll look sort of like JSON stuff, like maybe you'll believe that this looks like the information in the zip file, just sort of like those tweets. And it's stored, it's represented similarly with the JSON of curly brace, opening the JSON like a Python dictionary, then the key value pairs everywhere. If I want to take a look at some of these particular fields, so let's say I want to get the language of all of the tweets in this table, then so the name of this column is data. So I'll do data, and then an arrow. This is sort of like indexing into the data. And then inside of single quotation marks here, I'll put the lang field like that and hit enter. And now it gives me all of these languages in the tweets. Up here at the top, you can see that the column name is sort of like this undefined column name. The reason for that is, again, we have this function. This operator right here is implemented in Postgres as a function. And so it doesn't know that maybe it should be calling this lang or something sort of semantically meaningful. And anytime you use any of these JSON operations, you're going to get these weird column names. And so you can fix that, again, with the column alias, something like that. One of the, so that's the language. One of the important fields inside of here is where the hashtags are stored. And that is in this entities object. And so I just want to take a look at what these entities look like here for a second. I'll hit enter. And again, it's this super big results because each row potentially has a lot of entities. This first tweet right here has not so many, everything's empty, but there's 4 different sort of fields, entries, URLs, symbols, hashtags, and user mentions. And this tweet happens to have none of them. Down here, the second tweet has a lot more information buried inside of it. It has URLs, empty, but then this media one has a whole bunch of stuff inside of it. And so let's say that I wanted to get, I want to ignore all the other stuff and just get the hashtags out of here. I can chain together these sort of arrow symbols to do multiple indexing. So that, and then hashtags like this gives me all of the hashtags. So this sort of indexing like this in Python, that would look something like data, entities, hashtags. That's the SQL comment. Any questions so far about these arrow signs or the JSON syntax? One of the maybe confusing things here, and this is again related to quotation marks, is that you want to make sure that you're using single quotation marks always to something that's to the right of the arrow sign. The single quotation marks indicates that the thing inside of here is a string and not a column name. That's a little bit confusing because the things that we're referencing in the JSON, come back here, scroll down. These things right here are contained in double quotation marks when they're being displayed. And they're sort of like column names, like it's an entry here, a URLs field, a symbols field, a hashtags field. So it might be tempting to use double quotation marks, but if you do that, you're going to get some syntax errors. If you do something like this, then we'll get something like column hashtags does not exist. If you put double quotation marks right here, it's intending this to be another column name, and so it's going to index data by this other column, not what we want. So always single quotation marks is the thing that you want to use. This hashtags field, I'm gonna let's just add a limit 1 over here so that let's do limit 2, just so that it's fits nicely on our screen and we can see what's going on. You can see that the hashtags is represented as a list. Inside of JSON, JSON can contain dictionaries, curly braces, and lists. Whenever we're indexing into a curly brace, the arrow is for indexing into a curly brace. But if we want to index into a list, we cannot use the arrow. Instead, so if we want to index into a list or get the results out of a list, we have to treat it sort of like an array in Postgres. Treat it like an array and unnest it. The unnest operator only works on arrays, though. It doesn't work on these JSON types. And so the equivalent to unnest for JSON-B types is, and I have it listed right here under our notes, this JSON-B underscore array underscore elements type. This is what you want to use anytime you're extracting information from a list in JSON. JSON-B underscore array underscore elements. So I'll hit the up arrow, come back here, and I'm going to do JSON-B underscore array underscore elements like that on hashtags. And now this gives me, it broke up those hashtags into their own separate lines. I'm going to redo this command in a slightly different way. I'm going to do data dash ID over here, comma, all this stuff over here. The data arrow ID, so this is going to give me the ID of the tweet. And then on the right-hand side over here, this is going to give me all the hashtags that correspond to that particular ID. Hit enter. And so you can see over here on the left, this particular tweet has a really, all the tweets have a really long ID. But this tweet, there's 4 of them right here. So it had 4 hashtags that were used inside of this tweet. These 4, 2 coronavirus ones and then 2 German ones. And all of those hashtags correspond to this one particular tweet. If I take away this JSON array elements and look at that again, like this, here is that same tweet that we saw before, and here is that list of tweets. 2 coronavirus tweets, and then the 2 German tweets, or 2 German hashtags afterwards. We can see that this one up here, and these other ones down here, they're not going to appear in that JSON-B array unnest function call because they have no hashtags associated with them. And just like the unnest function takes empty arrays and basically removes them from our results, the same thing will happen with the JSON type. Any questions so far about the JSON-B array elements? Okay, last thing related to the JSON-B array elements is, so let's see, I'll rerun this command, look at the contents, and we can see over here the contents of this stuff to the right is another JSON-B object. I know it's JSON-B because it's contained in the curly braces, it's a dictionary, and so if I wanted to get the actual like text of the hashtag for this particular tweet, I would have to index into this text position right here. So after calling JSON-B array elements, I can add my index into text like that. And now it's giving me the actual the actual hashtags over here on the right, and we got the column or the tweet IDs over here on the left. Almost done with all the things that we need to know about the JSON-B type. But there's a distinction. I'm going to come back over here. There's a distinction between an arrow with sort of like one arrowhead and an arrow with this double arrowhead. And that's something else that can be potentially confusing. So we'll talk about that next. What exactly is the difference? And so let's say, so if we rerun this again, looks like over here we have a bunch of strings over here. Maybe we want to do like our various string operations on those strings, like, oh, I don't know, let's try converting it to uppercase. Like that. And we get this weird error message saying no function matches the given name and argument types. But we know that the uppercase function does work on strings, but for some reason it's not working on this result right here. Like, redo this. So here I'm not using the upper function. Hit enter. It sure looks like I'm getting a string over here, and so I should be able to call the upper function. But it turns out I can't call the upper function. When I do this, I get this error message. The reason is because whenever you use this, this arrow with a single arrowhead, the return type of that arrowhead is going to be another JSON-B object. In order to illustrate this, I'm going to use the PG_type of command like this. PG_type of tells me the type of whatever this variable inside of it is. I'll hit enter, and you can see that the type of all of these variables is JSON-B. Anytime, again, you use the arrow with a single arrowhead, the return type is going to be another JSON-B. The reason this is sort of the default is because that lets you chain things together. That when I did data and then access entries, this will return a JSON-B, so I can once again access that with another arrowhead to get the hashtags. That returns a JSON-B, so I can use the JSON-B array elements on it. That returns a JSON-B, so I can index into the text. The very last thing that you want, though, after you're done doing all of your indexes, you don't want a JSON-B anymore. You want like the actual type of whatever it is. And so that's when you add the double arrowhead. The double arrowhead gives you the actual, we say it resolves the type of JSON-B down to whatever it's supposed to be. And in this case, the text field is a string, so it'll come back as text. I hit enter, and now the PG type of is text for that, because I changed the single arrowhead into a double arrowhead. And so now with the double arrowhead, I can in fact do something like uppercase all of those tweets over here. So the takeaway message from all that is that you want to use the single arrowhead anytime you're like chaining things together, and then the very last chaining that you're doing, the very last arrowhead should be the double arrowhead like this in order to get the actual concrete type out. Any questions about any of that, Kieran?
So it's like the double arrow is like casting the type for that?
Yeah, so the correct verb to use is resolves. It resolves a JSON-B type into whatever type it's supposed to be. This is sort of like, so what's the difference between the verb resolve and the verb cast? When you cast a type, you're saying you specifically know what the end type is going to be. But when you resolve a type, there's some ambiguity about what the future type might be. So in this case, it became a string because the type was a string. But if it was an integer, when we resolve the type would become an integer. So it's like casting, but automatically figuring out the final type for us. Yeah, good question. Any other questions so far? Okay, so back over here, and back into, I want to take a more detailed look at our schema file down here. And let's do a :E again, just to remind ourselves exactly what the name of our file is. So I'm currently looking at the denormalized version of the schema file. And again, I know it's the denormalized version because it has the tweets_JSONB table right here, which contains this data JSONB column. Turns out that in this assignment, you're not going to have to actually write any select statements. So you're not going to have to write any of these accessing methods. I've already written those for you. And if we scroll down in this file a little bit, so scroll down, I've created a handful of views that automatically access this, this table here in the correct way. So we have create view tweets, and then it's selecting all of this information from tweets_JSONB. And it's in particular selecting information so that the schema of this tweet view, again, a view is just like a shorthand for a particular select statement. The schema of this tweets view is going to match the schema of, let's find the tweets table right here, is going to match the schema of the tweets table in the normalized version. :E on the right over here, we see PG normalized. So this is the normalized database. And there we go. There's all the columns, all the information that we have about tweets. And if we looked at the denormalized version, we would see that all of this information just matches exactly. So we have the ID of the tweets, the ID of the user, created at, ID of the tweets, ID of the user, created at, and so on. Up here, I can do something like select, let's count how many tweets we have, select count star from tweets, and it'll count however many tweets we have in the database.
Quick question. So when you were trying to index the JSON file, is there equivalent to like a ER diagram for the JSON file? Like, how did you know from the structure that you're not like constantly trial and error?
Yeah, that's a great question. The question is, how did I know like what the structure of the JSONB column was, or yeah, the JSONB column. Over here, we have this JSONB column, and then I'm doing a whole bunch of like indexing and such into it. And like here, when I do this data arrow created at, how do I know that created at is an actual like field in the JSONB column? The answer is I don't. The JSONB has no way of enforcing a schema on the type. And so this is both a good thing and a bad thing, that it makes our data more flexible, makes it easier to like shuffle data into the database. But it's a bad thing because it makes it really easy to put incorrect data into the database. And then if we don't have a created at field inside of here, then we're just going to get what this will resolve to null. So up here, let's come back to, there we go. So we had this like query over here where we had our IDs and our hashtags. And if I were to make a typo somewhere in here, say like instead of hashtags plural, I say hashtag like this, then there's no error message that happens. It's just giving me empty results right here. So this is one of the reasons why I think, or maybe, yeah, over the next couple of class sessions, we'll be comparing like advantages to disadvantages of the two different ways of storing the data. And I think this is a major disadvantage of the JSONB type, is that there's no like enforced correctness. Yeah, good question. We'll be revisiting this question sort of throughout the next class periods. So. So exactly, you can think of, so MongoDB in particular is every like Mongo database is just this table right here. There are other sort of NoSQL or features of NoSQL databases, which we'll be, again, going into over the next few weeks as we talk about efficiency of Postgres. And just like we can sort of downgrade Postgres like from a fully relational thing like this down into a a JSON store like this, we'll be able to downgrade Postgres' other features back down to a NoSQL thing. So yeah, everything that a NoSQL database like Mongo can do, Postgres can do, but it can also do all this other stuff as well and combine it all together in the same data store. Good questions. Any other questions so far? Okay. So why do I have these views here? If this were like a production sort of system, I probably would not have views like this that that take a JSON-B and give me a normalized representation of that JSON. It's just sort of a like weird kind of funny thing to do, that if I wanted a normalized representation, I would probably just normalize it to begin with when I'm loading things up. And for this assignment though, the reason I have these views here is so that I have a consistent common interface to both of these two databases. I can access the denormalized and the normalized database with the same queries. Inside, so up here, I'm going to do ls SQL. Inside of the SQL folder, there are a handful of just SQL statements up here. And in your previous assignment, you had to implement these SQL queries. In this assignment, I'm giving you all of the SQL queries, exactly what they already should be. These simple queries are, as the name suggests, pretty simple. Let's go ahead and open some of those up. Let's do, so SQL/simple, and let's practice our Vim skills of opening up multiple files at once. So star like this. I'm gonna forget the -P right here. We'll see what happens. I hit enter. You can see there's no tabs opened here at the top because it's only opening one file at a time. If I type :Q, it says there's 3 more files to edit. Wait, you can't quit. So you have to do :QA to quit. The A stands for all. -P loads them and puts them all in their own separate tabs like this. And you can see that these simple queries are all they're doing is selecting count star from the different number of, or from the different tables. And each one of these tables is an actual table in the normalized database, and it is a view in the denormalized database. And because they both have the same underlying data, we should get the exact same results for both of them. The complex queries, so I'm going to do, let's do :QA to quit out all of these. Let's do vim SQL/complex *P to open up some of the complex queries. And so here you can see these queries are doing sort of the things that your MapReduce Twitter assignment was asking you to do, like counting how many times the coronavirus hashtag was used. And this is the corresponding SQL for doing that. And we do that, I don't know, it has a handful of different queries doing various levels of complicated things. And yeah, each one of them has some sort of English explanation up top, which might help you if you have to look inside of here. But you're not only do you not have to modify any of these queries, you can't modify them, that you'll get, bad things will happen if you do that. So you don't modify any of these SQL commands, they're already like given to you. So that begs the question of like, what are you supposed to do in this assignment? And the answer is you have to load the data into the database correctly in this assignment. That's the tricky part of this assignment. In the other assignment, I loaded the data and you wrote the select queries. In this assignment, I wrote the select queries and you are going to load the data. And what we're going to see with this is that loading data into the denormalized database is going to be super, super easy. But loading data into the normalized database is going to be super hard. There's 2 files that you'll have to be modifying, this loadtweets.py and this loadtweets.sh file. Let's go ahead and open up loadtweets.sh. And there's 2 for loops right here that you're going to have to use. One loading into the normalized, one loading into the denormalized. Each of these for loops is going over all of the files listed in this $files variable. $files is defined right here. And so at this point in our assignment, we're just using this super small testdata.zip. But when we're working on the larger subset of, or when we're expanding this so that it's not just this tiny test data set, but actually like the full set of tweets, we're going to change this files variable to list all of the different zip files that we'll be working with, and this code will continue to work. So there's a common practice when working with large-scale data sets, testing them, is you first just get it to work, pass your tests on something really tiny that you can get really fast iteration time with while developing. And then after that works, then you change this to the actual full data set. With the normalized version of the database, what you're going to have to do is you're going to have to call this Python file over here, this loadtweets.py file. And we'll see how to do that in a little bit. And then with the denormalized version, there's no Python that you have to write. There's just a single pSQL command that you're going to have to put right down here in order to load things into the database. Switch back over to the notes down here, and let's scroll down. Let's say, yeah, we sort of talked about, well, I'll come back to this. So we're on this section 5 right now. So inserting the data into SQL, you can use either insert command or the copy command. For your homework assignments, right here, oops, where did I go? Yes, right here. In the denormalized, you're going to want to use the copy command. We'll see later why this is the case, but it is much faster than using the insert command. And you can directly import both CSV and JSON data without doing any pre-processing. The syntax for the copy command that you'll want to use is this thing right here. You'll just have to modify everything that's inside of the less than and greater than signs so that it sort of matches what it's supposed to be. So this thing right here, you'll be needing to cat the contents of the JSON file. And then the table name is going to be tweets_JSONB like this. And the column name will be data, and so on. And you're welcome to just copy and paste this and treat it like magic. Or if you want to know like exactly what all these weird details are, there's a reference right here that you can look at. But for the denormalized, it'll just be this one, basically this one line right here. Any questions about that? Okay, I'm going to really quickly switch over to my solution branch, check out solution. And I want to see what happens when I run this loadtweets.sh file. One of the things that'll be different about this assignment compared to the previous ones is that the loadtweets.sh file should be run from the Lambda server and not from inside of a container. The reason for this is because it's going to be manipulating multiple different containers at once, and so we don't want it like inside of a single container attached to that one container. And so if we run this loadtweets.sh, here you can see that, so it's loading the normalized. And you can see that it takes actually quite a long time to load tweets into the normalized database. Every one of these it's broken up into like chunks of 1,000, and it takes almost a second, maybe half a second to a second to load 1,000 tweets into the database. I know at first that might seem like reasonably fast to you, like, oh, half a second, who cares? That's nothing. But that's only 10,000 tweets, and our final data set that we're working with contains somewhere between like 10 to 20 billion tweets. And so this is super, super inefficient. We'll be talking later on how to make this more efficient. But for this assignment, just to keep things simple, it's going to be inefficient, and that's okay. And you can see down here with the copy command, again, that took significantly less time to actually run. I'm going to actually open up I'm going to open up the loadtweets.sh. This is the solution in the solution branch, so you can see what my solution to the loadtweets.sh looks like. That's just calling, so up here, Python loadtweets.py, down here, timing this big command copied and pasted from the notes. And you're welcome when you get to the point of actually implementing this. This will all be loaded up on YouTube, so you can open it up, scroll to or find the right spot in the video to see this, and just pause the video and take a look at the solution and basically copy it over verbatim. But I've also included this time command right here so that we know like how much time each of these two calls is taking. These portions right here, these two lines right here, tell me how much time the previous command took. So up here it took, I don't know, 4.3 seconds to load up these 10,000 tweets up top. Down here, using the denormalized version, it took 0.2 seconds to load the denormalized data. So this is significantly faster than the normalized data up here. And so that's going to be one of the advantages of the denormalized representation, is that loading data will be significantly faster. In the, so that's the loading the denormalized down here. Let's take a look at what this loadtweets.py actually looks like. Before I do that though, I'm going to switch back to our master branch. And then over here, tab e loadtweets.py. And inside of this file, there's a handful of functions. This helper functions section up here contains some functions that you'll have to work on, some that you don't have to work on. But I'm going to jump back down to the bottom of the file down here. So I press Shift-G to go to the bottom of the file. And anytime I'm sort of working on a script in Python, and I'm like just looking at it for the first time, trying to figure out what it's doing, I always, in Python, you start from the bottom up on the file, not top down. The reason for that is because the bottom of the file contains this line right here, if name equals main, and this part is what actually starts the execution of the script. The stuff up above, before this line 259, is a bunch of function definitions, which we'll need to refer to understand what's going on. But this is like where the script actually starts executing. And so it's loading some command line arguments. And then this right here creates a database connection. This is using the SQL Alchemy library to connect to the database. And one of the advantages of the SQL Alchemy library in Python is that you can connect to any database with SQL Alchemy. So we're connecting to Postgres right now, but you could also connect to MySQL or Oracle, MS SQL, SQLite, what have you, and using all of the same code to do those connections. We can come back over to our notes and scroll down to this connecting to Postgres from Python section. And so again, just a description of SQL Alchemy right here. We talked a little bit about ORMs at the beginning of our discussion of SQL, saying that I don't like ORMs personally. They hide the SQL from us. SQL Alchemy has an ORM built into it, but we're not going to be using that in this class. And instead, we're going to be interfacing directly with SQL. And so SQL Alchemy is just going to give us a standard interface that we can pass SQL commands to any database. These commands at the top, you always have to create an engine for SQL Alchemy. The URL right here is, I guess, an important thing for us to go over right here. To the left, Postgres QL:// you just, in order to use a different database, you just change this to SQLite or MySQL, whatever database you want to connect to, and SQL Alchemy will handle the differences under the hood for you. You have your username, password. So these are the things that you'll have to get from the, so let's come over here, open up the docker compose.yaml file. We have our username and password. In this case, it's just defined directly in the docker compose.yaml file. You have to make sure you get this information correct in order to connect to your database. And then a host :port. The port is going to be whatever the number is over here to the left of the colon. on the assignment, it starts off as being 1. You'll have to change that to something else. And you'll have to make sure that the URL that you're connecting to contains the correct port for whatever you have changed your Docker Compose file to be. And then the name of the database over here. If you look back over here at the load tweets.sh, there's this --db flag that I have, and here's the actual URL that I have that I'm connecting to the database with in the load tweets.py file. So your final connection will look something like this, but it'll have a different port number that corresponds to whatever port number you select for your ports down here. Next thing that's going to happen in Python is that you'll have what's called a connection. And for scripts like this, so there we go. For scripts like this, it's common to have just a single engine and a single connection object. If you are writing a web server or anything that has multiple users interacting at the same time, you would have a single engine variable for your script and one connection object for each sort of user that's independently using the system. So if you're using Flask, this connection gets created for each route has to create its own connection, but the engine can be shared across all the routes. The next thing, all this stuff down here is looping over the input file, whatever gets passed in, the zip file, to extract all the text. And then eventually, once we get the text in this line variable right here, we pass it to this insert tweet function, which is going to do all of the actual hard work for us of inserting the tweet into the database. And so this is the function that we're going to have to that you're going to have to implement. In order to go to the definition of a particular function, what you do is you type G and then D. So G for go, D for definition. Technically, Vim doesn't understand the semantics of your code at all. It doesn't understand the semantics of DEF is for defining a function. And so what GD actually does is it takes you to the first occurrence of whatever word is under the cursor when you do that. And in the vast majority of programming languages, they must be written top to bottom, and so that'll take you to the first, to the actual definition of that word. If I want to go back to where I was in Vim, pressing the single quotation marks twice takes you back to wherever it previously was that you were at. So again, GD takes me to insert tweets, and then quotation mark takes me back to where I was. If I want to look for all the different places where a particular word is used, I can press the star button, so Shift and then 8 on an American keyboard to hit the asterisk key, and that just cycles through all of the uses of whatever word is under the current cursor. So it's like a search for /insert tweet, but it does all that slash and typing it in for you automatically. And in this case, we can see that the only place where this function is actually used in this script is down right here in this loop. Inside this function, most of this function is already implemented for you, but scroll down to some parts where you'll have to implement. There are a handful of lines that look something like this, where it says something like SQL equals SQLalchemy.sql.text, and then it has this empty quotation mark right here. What you're going to have to do in this assignment in order to make your implementation work is you're going to have to put the correct insert statements right here so that it actually inserts information into the appropriate table. Up at the top on each one of these sections, I have like a little header information telling you like exactly what is supposed to happen in this section. So insert into the users table. And if there's any sort of like computation that needs to happen for the values in that users table, it happens right here up at the top. So you won't have to like do any sort of computations. You just have to make sure that this information up here gets inserted into the table down here. Inside of Python, the way you do an insert statement, so the way you do any statement inside of Python is listed under this query section right here. So you put your SQL that you want inside of that SQLalchemy.sql.text like this. And then if there's any variables that are going to be substituted, like so here, I want to select the ID tweets from tweets where ID tweets equals something like this. Then this colon id tweets right here is going to be substituted with this dictionary value down here. So we have id tweets in this dictionary. This thing to the left, this key right here to the left of the colon, the key matches one of the things to the right of a colon up here. And this colon says whatever comes after it is not actually a SQL command. It's a variable from Python that's going to get substituted. And it's going to take this tweet ID value right here. And the SQL Alchemy library will automatically substitute that in for you. It's extremely important that you use this format of to insert things into the table and not try to like use Python string manipulation to insert things, because this execute function with this dictionary will properly escape whatever the variable is right here so that you don't get any bugs in your code. Turns out that users are evil and they will always try to break your SQL code. One of the most common bugs in production systems, whether it is a website or like a backend service or just a one-off script, is to have what's called a SQL injection vulnerability, where somebody who has like SQL code in their username can do bad things. So this is a real life tweet from somebody named Rachel True, who is not a software developer, just was not being able to work with iCloud because her last name was True, and Apple was interpreting her last name as the Boolean value true instead of the string true. Obviously a bad thing right there, but maybe not too bad. What would be worse is that if you have like somebody's username is like this right here, where this drop table students, the drop command actually deletes all of the content of that particular table. And so here, little Bobby Tables, when his name gets added to a database, the database just gets deleted if they did not properly escape their code. So this is the next KCD comment. That's sort of like the famous standard representation of this. But there are lots of like real world examples of this. So there's a UK security company where this is their actual like company name, legally registered. And so if you ever download a database of company names, this is going to be in that is going to be one of the names. And if you're not properly handling your SQL, then your database is going to get dropped. This is another name. This is inserting some HTML into the code. This one, though, because it was causing such problems for so many companies, a court ordered this company to change their name away from this to something else. So these are examples of, like, this is something that does happen in the real world, and on this assignment in particular, if you don't use this colon syntax, then you'll have things that don't work. Any questions on that colon syntax inserting or substituting variables like this? Okay. So in the code, there, again, in this load tweets, there's a handful of these sections where you'll have to actually provide the SQL code that's going to do that insertion, and you'll have to provide the actual call to the execute function that does the substitution for variables as well. And then each of these tables, so like the users table, there's not really much computation that has to go on to get the values into the users table. In the tweets table, there's a lot of computation that goes on here to extract the like geo information and stuff correctly. So you can see there's a lot of code up there that's needed, but then down here, you'll just be adding some insert statements so that that already correctly formatted information gets inserted. There is one of the subtleties, which we'll go into next time, is For the URLs, there's a table for URLs, and each URL needs to have its own ID. And so if you're looking for examples of how to insert things correctly, this get ID URLs is already implemented for you, and it does the insertion correctly. So here you can see it's inserting into the URLs table, URL values colon URL. We'll talk about what these things do next time, and doing the substitution properly right here. Yeah, I think that's a good stopping point for us for today. We probably have maybe 10 or 15 more minutes of talking about this assignment. But at this point, you should be able to do everything in the denormalized one. The only thing that's remaining is the talking more about the normalized. So yeah, we'll stop here. If anybody has questions about anything, I'll be sticking around after class. Feel free to ask about this or about Pagilla homeworks or anything else. Otherwise, I will see you next time.